Hey, I'm Jerry Hill, and I'll be your host today for My Career Conversations. My Career Conversations is a great way for schools and companies to connect with students and to learn more about career possibilities that exist in West Michigan in the advanced manufacturing field. I'm excited to introduce you to Michael Boss from NN Mobile, Joe English from Woodward Governor, and Paige Caffeine from Rockwell International. These people are career guides for today's session, but first I want to go over a few items before we get started. If you have any questions during the presentation, please submit them to the Q&A function on your toolbar. If you're watching as a class, you can jot down your questions for your teacher to submit. We'll take time after the presentations to answer all of your questions. There'll be a survey. We'd ask that you please complete when you're done watching today, and that your teacher will provide the link for you. Your feedback is very important to the data that we collect and to learn more about how effective our programming is. So let's get started. Michael, tell us a little bit about your position, what you do, and why you love it.
Okay, so I work for NN Inc. AutoCam, and we make very high precision auto parts for different suppliers like GM, Bosch. I work specifically in the Cummins area and in the Cummins Emission systems team. So what I do is I'm a manufacturing quality engineer. And what I do every day is I work with machinists out on the floor to improve their processes, to increase the quality of the parts that we make and the volumes that we're able to deliver to our customer in a timely manner. And it's much more than that. But let's just go ahead and start at the very beginning and what got me to this field. So when I was in high school, I didn't think much about manufacturing in West Michigan. We had a wood shop. I did wood shop. We had a metal shop back then. I did that as well. But I wasn't thinking that I was going to go into a manufacturing career. I actually didn't have much of an idea, as many teenagers coming out of high school. I didn't have much of an idea of what I wanted to do. So I just went to college because that's kind of what you did after high school, right? So I went to college and I completed a bachelor's in education, actually. And around 2009, 2010, I graduated with a bachelor's in K-12 ed, and I was having a hard time getting a job in West Michigan. I was a contract teacher, teaching English language learners how to read English and write English and working with them. And I was still struggling to find a meaningful career path for myself. And after about 2 or 3 years of that, I realized I needed to make a change if I wanted to have a career, because I was hitting dead ends in education. So I started doing some research, and I realized that West Michigan actually has a lot of opportunity in manufacturing. And I looked for apprenticeships, companies that would pay to teach me the skills I would need to be successful. I found AutoCam, and they had a program that would hire you in basically as a full-time apprentice machinist at a reasonable wage and pay for the apprenticeship to get you a journeyman's card, 100% free and clear. So I applied for that. And when I went into my interview, I was very honest. I told them, I have no background in machining other than a little bit of metal shop in high school years ago. Struggling to find work in education, even though I have a bachelor's degree and a teaching certificate and licensure, and looking to change paths. And I think this is a good route for me, a good fit. I'm good in mathematics. And they said, sure, we'll take a chance on you. We'll train you right on our floor, and we'll send you to school. And typical skills that it would take on a daily basis to be an apprentice machinist. Someone like me, I came right off the street with no idea what turning metal would be, running a lathe, what running any kind of equipment would be. But I was able to very quickly get training right on the shop floor. And here at AutoCam, we do a lot of lathe turning, which is basically spinning a bar of steel of some diameter and size and cutting it with tools to create a shape out of it, is what we do here. It's primarily 100% machining and grinding and working with metal. So I had no experience with that, and I would come in and work with a mentor. He showed me how to set up the machine, how to set up the stock in the machine, which is the raw bar stock, how to check my parts, everything that I needed to be successful in the field. And then every Friday, the company would send me to school at GRCC for an entire day, and we'd have an apprentice. We had an apprenticeship that was half class and also half out in the shop. So we were learning how to mill parts, and that's basically, a mill is different than a lathe, where the piece of steel is held by a vise that you guys may have seen a vise before in your garage at home or in a shop at school. A hunk of material, steel, is held in the vise, and a cutter actually moves against that steel to remove the material and create some shape, some finished shape. So I learned all of that in 2 years of school. AutoCam paid for it 100% free and clear. And then when I was done with that schooling, I was given a journeyman's card and also made a journeyman machinist out on the floor in the shop, making a very nice living doing that. But what I realized is that my company also offered tuition reimbursement. And the cool thing about the tuition reimbursement at AutoCam is that it isn't a traditional reimbursement plan where you pay up front for school and then they pay you back. They actually pay 100% up front. You just give AutoCam your bill for school if you're hired in, and they pay for your schooling. So I decided to go get my associate's degree and completed that in another 2 years. AutoCam paid 100% of it. I probably couldn't have done it on my own with the way that loans are and the way that school costs are. All the while I was making a career wage as a journeyman machinist. And then after that, I continued on to get a bachelor's degree through Ferris, all AutoCam paid, through the Manufacturing Engineering Technology program here downtown in Grand Rapids in the evening while working full-time on day shift, and completed that program, and they promoted me to manufacturing quality engineer. Now, in that time, there have been a lot of things that have changed in what I did day to day. So as an apprentice, you work with a mentor out on the floor. He's showing you all the basic skills you need, how to read blueprints, how to run our systems, how to check parts, how to adjust tooling and set tooling. And then as a journeyman machinist, you may have to program machines, set up machines. You may be mentoring other apprentices coming up through the programs. So as you progress through that system, at least in my path that I took, which was like an apprentice to engineering path, your job and skills change along the way. There was a 1 year and a half stint too, where before I became an engineer, where I became a CNC technician, and I was just involved in launching new equipment. And that meant that I would travel with a senior engineer to OEM manufacturers to basically check on machines that we're buying and also run them off. And I mean, it's very hard to to describe in detail everything that's involved, but you basically travel to a company that's making you a machine to basically do a specific operation on a part, whether it's make a finish correct on the outside of a part, or just turning the nose on a part, and you're making a very specific piece of equipment to do that for you. You travel to that OEM and you basically run a bunch of parts and you try to find anything wrong with that machine before it hits your shop floor. So I did that for a while, right at the end of my bachelor's in engineering. And say, what's that? I didn't hear you.
I asked if you could tell our students what NN Mobile makes as far as parts go.
So all kinds of different parts. I work specifically in the Cummins area. And when I started as an apprentice, I worked in the fuel systems area. And what I was making at that time were needles for fuel injectors. And it's just a very precise needle that's, if you have a Cummins engine, you have these fuel injectors in there. You may not ever see them, but they're in there, and they're very high precision, very tight tolerance stuff. I'm sure you guys have worked with rulers in your science class, in inches and in millimeters. We're dealing with microns at AutoCam. So when we measure anything, it's measured in microns. A lot of our tolerances are 10 plus or minus 10 microns, and a micron is 1,000th of a millimeter. So you can imagine it's pretty small stuff. Our machinists here are just as skilled under a microscope as they are at a machine controller, because we have to be, because we're always looking at very, very small parts. Now, the parts that I work on now as an engineer are emission systems parts, and it's for a new program in Cummins, because out in Europe and China and India, they're now starting to get their emissions code more strict. So Cummins needed a solution where they could sell their large diesel equipment and also meet the emission standards. So what we do here is we make a couple small components that go into a DEF spray system in an exhaust. DEF is diesel. What's the term? Diesel.
Emissions?
It's lost. Yeah, diesel emissions spray, basically. So, or it's diesel emissions fluid. And what happens is when that spray, that fine mist in the assembly sprays into the exhaust, it makes the exhaust burn clean enough for the standard. So we helped develop that program with them. We helped basically from their design all the way up to production. We started making very small samples for them, and they would run what is called the DOE, which is a design of experiments, on several different samples of different sizes. And what they would do is they would test those in their test equipment to see if the spray was the right cone angle of the spray. So think about like an aerosol spray at a can. You press that aerosol down, you get a spray cone. They can measure that cone angle and even down to the droplet size. And basically what they were looking for is a system that would run for the life of the vehicle without failing. So
Michael,
you can imagine.
How long have you been in your job?
I've been at AutoCam for 8 years, and well, this June it'll be 8 years. I've been an engineer just under a year.
Great. And I'm sure our students would like to understand a little bit about perhaps what your salary is like, maybe a range.
From what I can tell, the salary range for a manufacturing quality engineer at AutoCam can be anywhere, depending on your level, can be anywhere from 50,000, 55,000 to 100,000, depending on how long you've been doing the job, what your experience is, what level you are. We have baseline MQEs, we have level 2s, and we have senior manufacturing quality engineers.
And last question for you, Michael, before we move on to Joe, because we're want to stay on time here today. Um, what what advice would you give to a young person starting out in manufacturing that might be interested in quality control or precision metal grinding?
So the advice that I would give is find a company that has a good culture and values their employees first and foremost. Also look for a company that's willing to invest in you, that's willing to pay for your apprenticeship, that's willing to pay for you to get an associate's degree, pay for your college, with a that values your family time and has a strong team involved in it. But also, I would say that don't be afraid to try something new. If you want to get into quality, if you want to get into machining, grinding, don't be afraid to go in with only a good attitude, because I think attitude will get you a very long way. A little bit of aptitude and a lot of good attitude will get you very far in this field. So if you're feeling like, man, I never had metal shop, I've never checked a part with a caliper, I don't even know what a caliper is. Boy, that guy talked about microns. I never even heard the word micron. Neither did I 7 years ago.
Great. Hey, thank you, Michael. We really appreciate you sharing a window into what you do every day. It was very informative. We look forward to some of the students' questions.
Thank you.
Joe English of Woodward. Tell us a little bit about your occupation, what you do, and why you love it.
Sure. So I've actually got a couple of slides to share. Like you said, my name is Joe English. I work for Woodward, which is out in Zeeland, Michigan, West Michigan. I've been there for about 5 years, graduated from University of Dayton in 2017 with a degree in mechanical engineering. And at the time, I knew I was interested in aerospace components, airplanes in general. There's a time in my life when I was very young where I thought maybe I'd want to be a pilot. And so flight was always something that appealed to me, and how that works physically was always really interesting to me. So I wanted to get involved in that. And now I've been working at Woodward for about 5 years on the design engineering side. And lately I've been transitioning more into manufacturing engineering, where the parts actually get made, and managing that team, but still heavily involved in the design aspect of it. And why I love it really stems back to my interest in flight, my interest in the technology that I work with. I focus in additive manufacturing, which I'll get into, but being involved in that cutting edge technology, as some people would say, is exciting on a day-to-day basis. So I can just walk you guys through a little bit of what I do. So
Joe, could you speak up for us just a little bit, please?
Oh, sure thing. Let me move my mic up a little bit. Can you hear me better? Is that better at all?
Maybe a little bit.
Okay, maybe I'll speak a bit like this.
We hear you better now.
Jerry?
Yes.
Okay, all right. So in case you didn't hear me, at Woodward for about 5 years in design engineering, working with additive manufacturing. So Woodward as a whole, we make a lot of different turbine combustion components. Now that means everything in a turbine engine, like you see here on the left-hand side, and all of these parts here in red, if we zoom in on them a little bit, all of these different components, fuel controls, manifolds, sensors that will deliver that jet fuel into the engine and drive the combustion process for that engine. We make all of these little red components. Zeeland focuses on fuel nozzles, fuel injection, ignition. And the cool part is on the military side, we work on afterburners, which take you from a few hundred miles per hour to over the speed of sound, breaking the sound barrier. So it's cool to be involved in hardware like that. The rest of Woodward also makes flight controls and various hydraulic actuation components on a plane. So if you've flown in the past, I don't know, 60 years or so, you've probably interacted with a Woodward component in one way or another. So let's get into what AM is. So additive manufacturing is just simply a term used to describe any manufacturing method where material is added rather than removed. So where Michael was talking about milling or a lathe, turning and that kind of thing, material is being subtracted away until you reach your final shape that you want to use. For our process, my team focuses on additive, and that can mean plastic additive manufacturing, where you have say a vat of resin that gets processed by a light, and then you build it up layer by layer. Or some of you may have seen an FDM machine where a filament is deposited by a small head, and that runs around until you reach your final shape. But the process my team works with is mainly laser powder bed fusion. And I know this is a pretty busy slide, but maybe you guys will have a chance to look over this later. What we focus on is delivering this very fine metal powder. It's almost like dust into a working chamber. And then we take basically a laser and we weld that powder to surrounding melted material and the powder itself to build our shape up. And I'll have a little video that shows how that works. But once you fuse an individual layer, this platform moves down, and then you provide a little bit more dust, and then you weld that again, and you do that over and over and over until you've built up your part within the powder bed chamber. Now, there's a lot of other technologies in this space that I'm not going to focus on today, but really encourage you guys to look up because it's really interesting, and there's going to be a lot of opportunities for interested engineers and interested manufacturing people to get involved with this technology. So directed energy deposition is very similar to that FDM, where metal is welded and placed onto the hardware at the same time. There's some really cool developments out in California where people like SpaceX or rocket companies are basically 3D printing entire rocket combustors or rocket nozzles. You can look up some cool videos on that. And then there's other exciting technologies where they're combining additive manufacturing and subtractive manufacturing. So you would have one component of your machine that adds material up, and then you can have another component, say a tool that comes in and removes material to the exact final shape that you might need. So there's some really exciting developments going on, and working with at least laser powder bed on a day-to-day basis makes my job pretty interesting. So this is a quick look at what my workspace looks like on a day-to-day. When I first joined the group, we were in kind of a small, not quite a closet, but a small room, maybe the size of somebody's bedroom. We had one machine in there. Now we've quickly expanded to where we now have 4 machines. We're going to get 3 more printers this year. And this facility is all very safety centric. So that metal dust, you have to be very careful with to make sure that it doesn't either get on your skin or get in your lungs or combust, not necessarily in a very volatile way, but you have to be very careful with it. So we're very safety centric here. And the cool thing is we work with materials that are used in the jet engine, right? And that's a very harsh environment. The engine can get up to 1600, 1800, 2100 degrees, depending on where you are. So our materials that we work with right now can actually be used within, negative 60 to 1600 degrees Fahrenheit. And we have to be able to design for all of that. So my team works to make those components. Go through a quick clip. I don't want to take the whole time sharing this, but we made this a handful of years ago in 2017. That is yours truly, with a bit less hair on my face, more hair on my head. But this is a quick look at the machine. So when we load in a plate to get it started, we have to take a stainless steel build plate and actually bolt that into the machine. That's the platform that's used for everything else to be built on. We have to make sure that that's really flat so that those first welds have good adhesion to that build plate. Then we load in this powder and we actually run it through a sieve, kind of like what you might have seen in a sandbox when you were growing up, to take any of those really big clumps out, essentially. We flatten that out and make sure that the machine is ready for those first couple of layers. Again, just to make sure that those first layers are good so the rest of the process is stable. So this is a top-down view, and now we're on the side, showing the laser actually welding that dust to the metal plate. And it looks like it's moving across in a band, but really what that is doing is moving at nearly 1 meter per second at a small spot size, jumping back and forth across the part. So it looks like a band, but it's actually just moving that quickly. And this is going to be fast forwarded, but if I pause, you'll see this middle platform move down. This recoater arm will come across and then provide a new layer of powder. We repeat that over and over, say 2,000 times, and then your part is done. You'll see our technician is going to clean this out. The only, excuse me, the only solid material in there is what's been welded together. So there's a lot of extra powder that we need to remove and reuse. But then your final shape is really only where that laser has been applied. So that allows us to generate really cool 3D shapes, these lattice structures on the outside of the parts, and really have a new design space that maybe we wouldn't have been able to work in, say, 20 years ago. Because these parts are welded to the steel plate, we have to separate them. And we use what's called an EDM, so an electric discharge machine, I believe it's called. So there's a wire that moves across there and it's charged electrically. And as that moves across the parts, it actually cuts through the material and separates it out. And then we have our final working piece there. Here are a couple other examples of what we've done in the past. Some cool.
How long does it take to make a part like that, Joe?
That part we looked at took about, I think we printed 5 of them, and it took about 24 hours. The slow part of the process is that each layer is 0.0015 inches thick, which is thinner than the normal piece of hair, basically, from what I've been told. I think a piece of hair is 0.002 inches thick. And we build each one of these little stacks up in even smaller increments than that. So it takes a long time, but for aerospace components, we have to be very, very precise. We have to make sure the material is very, very dense. We can't have any holes in there or anything like that. So that's how our process works.
Great, thank you.
So some cool different components here. Obviously, this type of connection isn't something typically seen on conventionally manufactured parts. This is a heat exchanger. So if people aren't familiar with that, typically what you would do is feed, say, fuel into one side, and say that's hot fuel. And then you would take another cold liquid, maybe cold oil, and they run side by side inside of a thin walled structure. And that allows you to cool one and heat the other and exchange the heat between the two fluids, and then continue that downstream for whatever, say, engine or process you're working in. But this 3D manufacturing technology really opens that up. And then everybody likes a good fire, likes a good flame. And so working at Woodward and working with combustion components, we do get to ignite things every once in a while, which is always exciting. So a photo of one of our combustor cups. A little bit more about what our engineering team does in general. So my group is pretty highly focused in the AM space and those machines, but we have a pretty large engineering team and a lot goes into these fuel nozzles. So if you think about a spray hose attachment, a nozzle at the end that you would use, you can change that tip. You can rotate that tip so you get a jet or a cone spray or a flat spray. Our customers send us specifications that say your spray should look like a cone at a very specific angle, and we want each little droplet of fuel to be only 70 microns so that it's easier for it to light off, so the combustor can be more efficient. And so we test that. We send lasers through the fuel spray and then capture data to understand what those droplet sizes are. We spray through, say, a flat bed of lasers to capture what the different focus points of spray may be. If we have a 6-point injector, we can look at where the spray is focused and where it's more light. And then we have our own test facility where we can actually light off components in a really long rig running extremely hot air, say 900-degree Fahrenheit air around our components, and then attempting to light that off. So there's a lot that goes into this. And it's not just the day-to-day testing, but we do a lot of computer simulation around this work as well. So before we build the parts, we'll simulate what's my spray going to look like? What are my drops going to look like? All of that stuff. So there's a lot of different avenues. If you're more computer centric, or if you're more hands-on, I want to turn a wrench and put these things together. There's a lot of different opportunities. So I think that wraps up at least my presentation portion.
Yeah, thank you, Joe. Great job.
Thank you.
Hey, I think when I was in high school, I didn't even know that additive manufacturing existed. How did you get interested in that field?
I was very lucky with my timing at Woodward. And when I came in for my internship, they were gearing up to bring a lot of this technology on board. And so I was able to get my foot in the door early. And I didn't really know much about it either, honestly. I knew about 3D printing, but I didn't know that it was going to be used on aircraft parts. So the timing was really the thing for me. When I took my internship with Woodward the year before I was hired on full time, they were gearing up. And so I kind of got in on the ground floor. And I say lucky, and I've mentioned that timing to a lot of people in the past, and I've been corrected by a couple people that say it's one thing to be lucky when you're looking for a job or you're looking for a career, but it's another thing to say that you're seizing the opportunities that are in front of you. I could have taken a job somewhere else and it would have worked out great, and maybe I wouldn't think that I'm so lucky, but it's just about taking the opportunities that are presented to you if it's something you're passionate about.
Thank you, Joe.
Yeah.
Really appreciate your time, and we're looking forward to the students' questions for you at the end here.
All right.
Last
Thank
but
you.
certainly not least, we'd like to introduce Paige Caffeine. Paige is from Rockwell Automation, and she's here to tell us about industrial sales today. So Paige, welcome.
Thank you. I am going to get my screen shared here. I've got a little presentation for you guys and a video as well. So once I get to the video portion, Jerry, if you could just give me a thumbs up that the sound is coming through, that would be great. So as Jerry mentioned, I'm Paige Caffeine. I'm a technical sales engineer at Rockwell Automation, and I'm going to give you a little overview of who Rockwell is, and then how I kind of stumbled, I like to say, into my career as a technical sales engineer, and include a few lessons that I learned at your age and a few lessons I learned through college that helped me get to where I am. So just a quick little overview. Rockwell Automation is a global company with facilities in over 100 plus countries. And our strategy is to bring the connected enterprise to life for our customers. So you might be wondering what the connected enterprise is. This is Rockwell's buzz phrase for Industry 4.0. So if you haven't heard, we are in our fourth industrial revolution. And in this revolution, we're seeing a lot more connected and smart machines that are going to use the augmented reality, algorithms, and live data that we collect from devices on a manufacturing floor. So Rockwell Automation helps manufacture those devices, and we also go out as a technical salesperson and help our customers who are manufacturing other products figure out how to make their business outcomes a reality using our devices. So I'm going to show you this quick little video on how Rockwell Automation touches your life, and it'll kind of walk through a few things you might recognize. All right, so Rockwell Automation might not be a name that you specifically have heard of, but we are behind just about everything and anything that is manufactured. And also in the video, you might have seen a roller coaster. Rockwell Automation has devices on roller coasters to help tell them where to go and how to keep people safe on that ride. So everywhere you go, you're probably running into our products and you don't even know it. We're actually the world's largest company dedicated to automation and manufacturing. And then you saw in the video, there were some devices that had blinking lights and that were controlling these robot arms that was making a vehicle. So we create those devices. We also create stack lights and monitors that pair with our software to help automate that manufacturing. So taking a look at these brands, you might recognize a few of them. I'm going to specifically take a look at the food and beverage red banner. So you probably recognize quite a few of these, but have you ever had a box of Kraft macaroni and cheese? Many of us have, and we not only impact the process of making the noodles and the cheese powder, but we also are in the facilities that help box up that product and take it to a store shelf. So we are manufacturing not only from creating the product, but helping manufacture how they get it into the boxes and get it to the shelf so that you can purchase it. And then speaking of getting product to places, if you've ever ordered from Amazon, we also are in material handling industry where we help Amazon sort and package products so that they can get it on a FedEx or UPS truck and get it to your door in 2 days. So we might not be those names that you recognize in your daily life, but we certainly are behind the scenes helping those their realities become something actionable. So what does a career in manufacturing look like? It's a really cool comparison to How It's Made, if you've ever seen that show. And if you haven't, I encourage you to YouTube How It's Made and check it out. It is very fast-paced to be in technical sales, and it's always changing. So one day I might be in a Kraft macaroni and cheese manufacturing facility, and the next day or even the next hour, I might be in a car manufacturing facility. So it's really cool, fast-paced. If you like that kind of stuff, you'll definitely like a career in manufacturing. We also have a lot of people that are retiring. So we need young talent like you guys to come in and fill those gaps. As people are leaving, we definitely need people that are passionate about manufacturing and technology. And the technology in manufacturing is advancing at very fast speeds. It's the best part, I think, about the job is that the technology is always changing and you get to be part of that cutting edge and get excited about how augmented reality is impacting manufacturing. So that's Rockwell and manufacturing. How did I specifically get into technical sales and engineering in general? So I always loved math and science, and here's a little a time capsule from about 10 years ago. But math and science were the subjects that I was really only good at. So I felt like I needed to embrace those and figure out how to make them a passion. So starting in middle school, I looked at what opportunities I had to advance my skills and found that there was a center for advanced math and science for the county. And so I had to go and take a chance and take a test to try to get into the top 20 of the county. And I ended up being able to be part of that group. And within that, it introduced me to programming through Lego robots, which many of you are probably familiar with. I also learned how to code, and I got to run my own science experiment through my chemistry class, which is what you see on that screen. I was showing the product I had made from a sunscreen test that I was running. So from there, I moved into high school and I got a job at a controls lab at Whirlpool. So that's a picture of me in my lab. And this is where I learned a lot of the hands-on skills that an engineer would see. So I learned how to solder circuits. I learned how to build test stands. And I also learned the importance of life cycle testing for products that are meant for households, because as a consumer, you want to purchase a washing machine that's going to last a very long time. So I learned a lot of those hands-on skills, and it just reassured me that I wanted to go into engineering, and more specifically, electrical engineering. So then I decided to take that appreciation for engineering and attend Western Michigan University as an electrical engineering student. And although I learned a lot about circuits and electrical theory, I think the most important thing that I learned was how to think like an engineer. So it doesn't matter what discipline you want to go into, or if you even want to end up in engineering, that thought process is a really strong skill to be able to learn through school. So what does that look like? Really, it's how you approach problem solving, and really your focus and mindset around how am I going to get from point A to point B. And through that could be design iterations, taking in data and analyzing it, and then testing through those designs. And of course, continuous improvement, because we're constantly trying to re-engineer and make the best and latest and greatest. So learning that engineering mindset will flow through all of these different engineering disciplines, whether you decide to go electrical, biomedical, or even into trade school. It's a mindset that helps work through problem solving. So continuing through, so I went to Western, and while I was working through my education, I learned how to fail, and fail hard. So in high school and middle school, math and science were my forte. They were easy for me. And when I got to college, I failed my first class. I failed Circuits 101. And as an electrical engineer, that should be the easy class. So I really had to dig deep and figure out if this is really what I wanted to do. And through that, learning how to fail and move on was such a great lesson, because in my role, I still have failure moments, but being able to pick up and move on is what helps me continue to be successful. So I feel like that was a very big pivotal moment for me in college. So in college, I went through and did a design engineering internship and from a automotive manufacturing facility. And I was on their machine design team. So I got to learn all about how to design a machine and how to make it safe for manufacturing, because there was going to be human interaction with it. And this is kind of what led me to stumbling into technical sales. Although I loved design, it wasn't necessarily what I saw myself doing in the future, but I certainly wanted to stay in that industry. So it actually took a manager to tell me, hey, I think you'd be good at technical sales, and then me digging in and deciding that that would be a great path for me. The other thing is I joined a lot of groups like SWE, which is the Society for Women Engineers, where I got to go to conferences and surround myself with other women engineers that were going through similar situations and were great support mechanisms. So it was actually at one of the SWE conferences that I landed my role at Rockwell Automation and accepted a role as a technical sales engineer. And with that, I also accepted taking on a early career program that lasted 9 months, where I traveled to Cleveland, Ohio, Milwaukee, Wisconsin, and Philly. And so I got to learn about how the company operates and also about all of our automation devices. So I got some of that technical hardware training, but also some of that business aptitude that comes with being in technical sales. So if you like kind of both of those aspects, technical sales is a great avenue to go through. So I got to also work at our largest event at Automation Fair and talk about our devices to people that were attending. So when you're looking at careers, definitely take a look at companies that might take you places across the United States and even into overseas. So if that's something that you're interested in, definitely look at a company that has those opportunities. And if not, then make sure you're looking at a company that stays more local. So what does the day in a life of a technical sales engineer look like? So that's a question I struggle with because every day truly is different. This was an example of a busy day for me where I was training some people. I went to a customer training. I did some problem solving for a customer. I did some strategizing for how we could increase sales. I did some one-on-one work with my manager. And of course, through all of that, emails and phone calls. So with technical sales, it's a really flexible job. So I could be working 8 to 3 one day, and the next I might be working 7 to 6. It really just depends on how much time you need to get the job done, because we're more focused on deadlines as opposed to hours in the week. So I really appreciate the flexibility of my job, and it's something that I didn't realize I would enjoy until I took a role in technical sales. So that's my day job, but on the side, as a technical sales engineer, I get to also volunteer for outreach, teaching kids about STEM careers and how to do little experiments at home. I also get to judge at FIRST Robotics competitions, so some of you might be involved in that. So if you see me, wave, say hi. I get to mentor interns and trainees. So that was my intern from the summer. Even though she is much taller than me, she was the younger one. She was the intern. So that was really fun to be able to develop somebody and then stay connected with internal groups of women that are also in technical sales. And finally, being able to go to different conventions across the states to represent the country or the company and to learn all about the new technologies. So on top of being a technical sales engineer, I get to do all the stuff that I love and I get to travel. So I hope you learned a little bit more about what being in technical sales is, and I look forward to seeing many of you join our team in the future.
Paige, that was wonderful. Thank you so much.
Thank you.
A lot of great information from all of you and all of our career guides today. Thank you.